Final Project by Tian Kim, which is me. So this is my project overview. So my project is, do teens consume more than recommended 100 milligrams of caffeine per day? So the brief overview is just, this project investigates whether teenagers consume more caffeine than recommended 100 milligrams per day. How I collected the data was I used existing data, which is from NHANES. The original sample was randomized and represented of US teenager from age 13 to 19. So the background, which is the data source, which I mentioned before, which NHANES. It's a big national health survey run by the CDC. It looks at what people across the US eat, drink, including caffeine, which is the main subject for my project. The sampling method they use is a random selection process that makes sure the people in the survey is the representation of the whole US population. So this is the hypothesis testing. So my null hypothesis is that the mean is equal to 100 milligrams per day. So teenagers consume 100 milligrams per day on average. The alternative hypothesis is mean is greater than 100 milligrams per day. So teenagers consume more than 100 milligrams per day. I'll be using significant level of 0.05, and the test type would be one sample t-test, which is right-tailed. So the sample size I have is 3,280 teenagers. Mean caffeine intake is 55 milligrams per day, and standard deviation is 30 milligrams per day. So this is the condition check. So in order to do one sample t-test, we must do 3 condition checks, which are random samples, independence, and normality. So for a random sample, the NHANES uses a randomized multi-stage sampling design, so it's a check mark. Independence is each patient's caffeine intake is independent. Normality is with a large sample size, which is 3,280. The central limit theorem ensures the sampling distribution of the mean is approximately normal. So here's the statistics. So formula is T equals the mean minus the average recommended over the standard deviation divided by the root of the sampling numbers. So T equals 55 minus 100 over 30 divided by root of 3,280. So T equals negative 45 over 0.5238. So T equals negative 85.9069, and then the degree of freedom formula is n minus 1, which is 3,280 minus 1. So our degree of freedom is 3,279. And to get the p-value, we use the TCDF, so which is we use the calculator. We use the lower bound, upper bound, and the degree of freedom. So the lower bound is negative 85.9069, and then the upper bound is 999. And then the degree of freedom is 3,279. And so the degree of freedom and everything, I get TCDF of 1, so our p-value is 1, and our significance level is 0.05. So my conclusion is, since our p-value of 1 is way greater than our alpha level 0.05, we fail to reject the null hypothesis. We do not have sufficient evidence to prove that teens consume more than 100 milligrams per day. And here's my documentation. So at the side is a little screenshot of the NHANES where I gather my data. And at the side is the sampling test I did on the paper. And that's it. Thank you.